Robotics is an exciting field, but behind every precise movement and intelligent decision lies a critical choice. The control method in this video will explore how to choose the best control method for your robot, depending on your goals, the system, and also the constraint in the environment. Let's get started. Why is choosing the right control method so important? Control method defines how a robot interacts with the environment, moves, and performs tasks. The wrong choice can lead to the inefficient or ineffective and become a system failure. So understanding the objectives, the characteristic of the system, and the constraint is the key. So here is the main aspect you need to think about when deciding on a controls method. Okay, the first is objectives. Yeah, what do you want your robot to achieve? Yeah, for instance, it's a high precision like a robotic surgery, or speed and efficiency like a navigation robot or warehouse automation. And the second one is system characteristic. So, for instance, each robot has unique dynamics. A wheeled robot might need a simple control compared to the drone. The last aspect is operational constraint. So consider the environment and dynamics limitation. Is there any limited power? Do you need to work in a predictable condition or just interact with humans? Yeah. There's also essential factors that you must understand before choosing the right controller. So we look to some common control methods and when to use these methods on your system. And the first one is PID controllers. And PID control is great for simple tasks like maintaining speed or motion, but sometimes it struggles with complex systems and fast-changing environment. And the second one is Model Predictive Control. So we can say it MPC. MPC is excellent for dynamic and constrained components. It can predict the future behavior, but it requires a significant computational use. The next one is adaptive control. And we can see adaptive control, the parameter of the system can adapt with the condition of the system. And the other example is deep reinforcement learning. So this method is best for tasks that require learning from the experience. It's really powerful, but requires a lot of data and training. And it uses more computational than the other methods. Each method has a strength and weakness. The idea is simple but limited. MPC is precise but computationally heavy. And DRL, deep reinforcement learning, learns from scratch but needs extensive data and high computational as well. Choosing the right one often means balancing this trade-off. So here are some tips for you if you want to decide the controller. First, start simple. If your robot task is a straightforward PID or like LQR feedback controller is also possible. And the second one is for more complex tasks, you can choose MPC or DRL. As well as today we know a high computer with computational efficiency is really well known everywhere. And the next, always consider your computational resources. Don't choose a method that your hardware cannot handle it. The next one is do a simulation first. Use software like MATLAB or ROS, robot operating system, can test your control and implementation before the real world case. So let's see in action. Industrial robots often use a PID for a repetitive task, and self-driving cars rely on MPC for real-time path planning. Drones use adaptive control for stability in changing situations. Okay, so choosing the right control method is all about understanding your robot and its mission. If you found this video helpful, hit the like button and don't forget to subscribe and give the comments below if you have any suggestions. So see you in the next video.